In this video, I'm going to show you how to go from degrees to radians and to convert radians to degrees. Let's start out with a unit circle. Two ways to measure an angle. If I made another ray here, I'd have an angle, and I can measure my angles in degrees. I can also measure them in radians, and that's why I've got degrees and radians up here. So let's talk about the unit circle. First, if I start with degrees, you need to see that degree symbol there so that you know that you're talking about degrees. If I do one revolution counterclockwise around that circle, what I get is 360 degrees. Now, I can do the exact same thing, and this time I can do it in radians. Notice the difference here. I've got 0 degrees and I've got 0 radians. You can abbreviate radians RAD. You don't have to see the word RAD, but if you need to know which is which, so anytime you're dealing with degrees, you need to see that degree symbol. If I did one complete revolution around, I've got 2 pi. So now, if I can go around once and I get 360 degrees, and I can go around again, and when I do it in radians, I get 2 pi, draw the conclusion that 360 degrees equals 2 pi. Well, you know, anytime you got an equation, you always have to isolate that variable. So I'm going to divide both sides by 2, and what I get is my conversion factor. 180 degrees equals pi. This is all you have to remember. You don't have to make this big deal about, if I'm trying to find radians, this is the fraction I need. If I'm trying to find degrees, this is the fraction I need. No, all you're going to do is you're going to go with this. So now, let's try a few, and you'll see exactly what I'm talking about. Problem number 1. You look at your directions, convert to radians. So I'm starting with 240 degrees. Now, I got a 50-50 shot which of these two fractions to use, but really, you shouldn't even have to think about it. You want to lose the degrees, and you want the answer in radians. So I'm going with the very first one. Now, right away, I can cancel out those degrees. Next thing I would do, what I do immediately, when I see n zeros, that means you're dividing by 10. Knock those out right away. Then you can figure out what number is going to go into both. So now you look at it, what are you going to divide by? There's nothing to really think about. 6 into 18, 3. 6 into 24 is 4. Multiply the tops. You've got 4 pi. Multiply the denominator. You got 4 pi over 3, and there's your answer. So you successfully converted. You went from degrees to radians, just like the directions asked you to do. Let's try another example. Example number 2. Same thing. So let me start out with my 15 degrees. You always start out with what's given. You want to go to radians. So what that means is you want to lose those degrees, which means the 180 degrees has to go on the bottom. First thing I'd cancel out, I'd lose those degrees right away. And then you got to cancel out. So 15 into 15, 1. 15 into 180 goes 12. Multiply the tops together, you got pi. Multiply the bottoms together, you got 12. And again, you did what the directions asked, convert to radians. And keep in mind, like I said already, all you need to know is your conversion factor. You don't have to try and think which goes on top, which goes on the bottom. And if you remember, when we converted from degrees to minutes and seconds, this is the exact same process. Example number 3. Start out with the 40 degrees. I want to lose the degrees, so the degrees over here has to go on the bottom, and the pi is on the top. This is the conversion factor that I'm using. Again, cancel out those degrees right away. And then you can see I've got zeros, which means I'm dividing by 10. Knock those out. It makes the problem so much easier to deal with. So now, 2 into 4, 2. 2 into 18, 9. Multiply the tops, multiply the bottoms, and you got your answer. Next example. Now I'm going in the opposite direction. I'm starting with radians, and I want to convert to degrees. So just like the prior problem, I want to get degrees in my answer, which means I need to lose the radians. So this is the conversion factor that I want. Right away, remember in the prior problem we knocked out the degrees. In this problem, we're knocking out the radians or the pi. Now you're going to cancel out whatever you can cancel out. 12 into 12, 1. 12 into 180 goes 15. Multiply the tops, and you got your 105 degrees. Notice that degree symbol is still there. You didn't lose that. So that's your final answer, 105 degrees. Example number 5. You got that negative in front. Doesn't make any difference. All the rules are still the same. All this is saying is if you were going to place this on the unit circle, you would be going clockwise versus counterclockwise. One other thing to keep in mind, if I had negative 8 pi over 4, 4 into 8 is 2, you know you have one complete revolution clockwise. So where it's 9, it's a little bit more than 2 pi, which means your answer has to be greater than, when I'm converting it to degrees, it has to be greater than 360. So before you even start out that problem, just think about that, and then that's a way you can double check. So let me write negative 9 pi over 4. I need my conversion factor. I want to get degrees in my answer. So right away I know what I'm multiplying by. I'm multiplying by 180 degrees over pi. Cancel out my pi's right away. 4 into 4, 1. 4 into 180, 45. Multiply my tops. Oh, there's nothing on the bottom in the denominator. Multiply my tops, and I've got negative 405 degrees. Remember what I said when I started the problem. The answer was going to be greater than 2 pi, in this case negative 2 pi, or greater than negative 360 degrees. And that did come true, so that's a good sign. Last problem. Starting out with 5 pi over 3, and I want to convert, and I want to get my answer in degrees. So first thing I'm going to do, using my conversion factor, 180 degrees over pi. My pi's cancel out. 3 into 3, 1. 3 into 180 is 60 degrees. Multiply my tops. The bottoms have all canceled out, so multiply my tops, and I'm left with 300 degrees.